Let's prepare on the TNPSC AE 2019 question paper. Question 121. A simply supported beam of span L carries a point load W at the center of the beam. The bending moment diagram will be what? Okay, so simply supported beam means it will be like this. So it's carrying a point load W at the center. So it's like this. Okay, so if this is the case, means the bending moment diagram will be like this only, because we have seen that when it is a point load, it should be a linear line only. So it's like this. So option C, triangle beam with the maximum ordinate at the center of the beam. Okay, so if the same case is with parabolic means, that is if it is with UDL means, then the structure will be like this in a parabolic shape. Question 122. The shear force and bending moment are zero at the free end of a cantilever if it carries a what? Okay, so if this is the cantilever means, at the free end there should be zero bending moment and zero force. So here there should not be any force at all. Okay, so when you see the option here, a point load at the free end, it cannot be there, because when the point load comes here, obviously a shear force will be there. Uniformly distributed load throughout the span, this is the right answer. You see the other options also, uniformly varying load with the maximum ordinate at the free end. So it will be like this. If this is the case, means also here the load will be acquiring, so shear force will come. Couple at the free end, if the couple is here, means moment will come. So option B is only right pair. Both the shear force and bending moment are zero. 123. The state of stress in plane element is shown in the figure. Which one of the following is the correct? So it's the Morse circle diagram. So when the normal stress only is occurring, obviously this will be the answer, option C. 124. The force in the member BD is what? So here it's a zero member force only. Okay, so here when there are supports in the bottom, when you see A and C is there, no, so there support reactions are there. So this 5 kilonewton will be oppositely given in that A and C support. Okay, so there won't be any force in the member which is direct to that, so obviously it is zero only. If the same case, if the 5 kilonewton is applied at the point B, means then the member BD will not be a zero force member. 125. The modulus of elasticity and modulus of rigidity are related by, so it's option D is equal to 2C into 1 plus mu. So C is also denoted as G also. With respect to K, means the option C will be right, that is E should be equal to 3K into 1 minus 2 mu. 126. The point of contraflexure, okay, so it's only given as contraflame here, is where? So where this is 0, the bending moment is 0, so that point only we call it as the point of contraflexure. Or you can say it like this also, where the bending moment changes its sign. So this is also another correct option. Okay. 127. A circular shaft of length L subjected to a torque T. G is the rigidity of modulus and J is the polar moment of inertia. Then the total angle of twist is given by what? So this we have studied in the torsion unit. So it's T by J is equal to C theta by L is equal to tau by R. So this is the relation we studied already. So the first two components alone they have taken. So when you keep this theta alone in the one side, you will get us TL by CJ. So the CJ is only written as GJ here. Both C and G are same only. It's the rigidity modulus. So option A. 128. If a solid shaft is subjected to a torque T at its ends such that maximum shear stress does not exceed tau, the diameter of the shaft will be what? Okay, so actually this is an important point for any design of shaft. To be safe against the maximum permissible shear stress, this diameter should be provided. Okay, so this I have left out in the lecture video of the torsion chapter. So if anybody is following the lecture there, means you can kindly note this in that notes. Okay, so here option C is the answer. So how they are deriving this means, we have the relation no, T by J is equal to C theta by L is equal to tau by R. So here the first and third relation they have taken. Okay, so here when you write that, T by J will be equal to tau by R. Okay, so here the T is equal to tau into J by R. So J by R is what? So it's the torsional section modulus. So we denote it as ZP also. That is only J by R. So what is the value of this ZP means? We have studied that already. So it is pi by 16 d cube. Okay. So you can write it as pi by 16 d cube into tau. Okay, so this will be the relation. So now when you take d in the one side means you will be getting t by tau on the other side and 16 by pi. Okay, so it will be 16t by pi into tau. The cube root of that will be equal to d. Okay, so you can keep this t in one side and do the relations. So you'll be getting option C as the right answer. Question 129. If sigma 1, sigma 2 and sigma 3 are principal stresses and sigma E is the allowable stress, the equation sigma 1 square and sigma 2 square, sigma 3 square minus 2 by m into sigma 1 sigma 2 plus sigma 2 sigma 3 sigma 3 sigma 1 will give you the sigma E whole square. So this belongs to the failure theory. 1 by m is the Poisson's ratio. So which failure theory? That's the question here. So there are 5 theories of failure that we'll be studying in the strength of materials. So out of that 5 theories, only 2 theories will be having this much large formulas. Okay, so you can remember like that. Other 3, the first 3 will be having a smaller formula only. So by seeing this itself, you can go for the option A and B, because strain energy theory and total strain energy theory, strain energy theory and shear strain energy theory only will be having this lengthy formula. So this is for strain energy theory, whereas in shear strain energy theory the formula will be root of sigma 1 minus sigma 2 the whole square by sigma plus sigma 2 minus sigma 3 the whole square plus sigma 3 minus sigma 1 the whole square. So like that the formula will be there divided by 2, because that is for shear strain energy theory. 130. If E is the Young's modulus and I is the moment of inertia, then the expression EI d power 4y. So it's the fourth derivative by dx power 4 is what? So it's the load intensity at the section. So this also we have already studied in the strength of materials. If it is dy by dx alone means it is the slope. It's d square y by dx square into ey means it is your moment. And if it is in terms of d cube means it is your shear force. So when the fourth degree comes, we can tell it as the load intensity. Thank you and keep watching.